All right. So last week we talked about this whole question, and I left this last question at the back. Okay, about electrolysis of copper 2 sulfate. Every time you are given a question, okay, every time you are given a question, what you need to do for electrolysis is write down the ions present. Okay, so copper 2 sulfate solution, copper 2 sulfate, hello, Eugene, hydrogen, and hydroxide. Okay, so we have already known. Ian, do you have this paper? The last page of the electrolysis paper. Yeah, that one on the last page. Okay. Now you can see if the twins are not coming. Ah. No, you can see here. They are not here. Okay. So it doesn't matter whether you're using carbon, which is inert, or copper, which is a reactive electrode. Okay. For the cathode, for the negative terminal, it does not change. So for the negative terminal, copper or hydrogen, which one do I choose? I want to sit down and cry. We have gone through this a million times. Copper, because it is a transition metal. If it is group 1, group 2, group 3, choose hydrogen. If it is transition metal, choose transition metal. Remember, copper, silver, gold, nickel, platinum, they are all transition metals. Okay? Now, it doesn't matter which one, you still choose copper. So the cathode, copper ion receives electron to form copper. And where does this copper form? The copper will form on the negative. Let's say this is negative, they don't tell you. So it will form on the negative terminal. For the cathode on both sides, the mass will increase because solid copper is depositing on the electrode. Okay, so that the mass of the negative increase, the mass of the negative increase for both. Okay, for the positive terminal, however, for the one using carbon electrodes, if I am using carbon electrodes, sulfate or hydroxide, who do I choose? Hydroxide. And hydroxide will go to the anode. And what will it form? Water, oxygen, and 4 electrons. So because it forms oxygen, what do you see? You cannot see gas. You see bubbling. You see bubbling. Hi, Jai. Ian, do you have last week's notes? Eh, Jit, do you have last week's notes? This is last week's notes. We are on the last page. Did you watch the video? Okay. So you can see bubbling, but does it change the mass of the electrode? No. So you see, for apparatus A, the mass of the positive electrode stayed the same. Okay, but there were bubbles seen, and the bubbles were oxygen. You get it? Okay. But if this is made from copper, copper is reactive metal in this reaction. Copper will dissolve to form copper ions. Okay, so at the anode, copper dissolves to form copper ions for apparatus B. This one. So because of this equation, the mass of the positive electrode decreases. Get it? And no bubbles. Okay. Explain why the mass of the negative increased in both apparatus. Copper ion receives electron to form copper. Or you can say, you don't need to explain the whole thing. You just have to say copper is formed, right? So copper atoms deposit on cathode or on negative electron. Okay, can you just have to mention that copper atoms are formed there? That's why it increases in size because it is only one mark question. Name the gas formed as bubbles are seen. Oxygen. Okay. Explain why the mass of the electrode in B decrease. So you have to write down this equation lah. This one, the anode. Okay. So the copper metal dissolves to form copper 2 ion. Okay, it's only 1 mark, sorry. I thought it was 2 marks. So you also write the equation now, just to understand. Remember, copper metal is a solid. Copper ion is a solution. Okay? So just what happens to the color of the solution in apparatus A and apparatus B? Alright. Done? Done for this one? Okay. For apparatus A, so let's look at this. For apparatus A, this is anode. This is anode. And this is cathode. This is for apparatus A. Okay? Anode and cathode. So overall, the copper ions become more or less in the solution. Overall, in apparatus A, this equation and this equation is apparatus A. Okay? The copper ions in the solution are becoming more or becoming less? Less. Because copper ions are taken away to form copper. So in the solution, there is less and less copper ions. What is the color of copper ions? Copper is pink. Copper ion in the solution. Copper sulfate is what color? Blue. Copper sulfate solution is blue. So they're asking you the solution becomes more blue or less blue? Less blue. Blue solution fades. Why? In A, copper concentration of copper ions decrease. Okay? Now, look back at your equations for B, for apparatus B. Okay, wait, you write this down first. We haven't finished, Sorry? Apparatus B, how? Change or doesn't change? Why doesn't change? No, you look at this. This is for apparatus B. This is the cathode. This is the cathode. And this is the anode. Copper become copper ion. Copper ion become copper. One copper become copper ion. One copper ion take out become copper. The concentration inside change or doesn't change? I put one in, I take one out. Change or no change? No change. Okay, you you want me to start speaking like toddler language? Okay, it stays the same because you're putting one ion in, taking one ion out. Understand or not? Okay, so in B, the concentration of copper ions does not change or stays the same. Okay? Noah, your school until what chapter? Final exam? Your next exam? Now teaching what? Now teaching
Now she's teaching
rate reaction.
ring reaction.
Rate reaction. So exothermic, endothermic finish already.
Finish.
Okay, so today we'll do that. Okay, this is what you need to do. You need to go home and study. Okay? Alright, I cannot teach you 1 week, then you forget 1 week like Dory fish like that. You're not a Dory fish. You cannot live such a happy existence. Every day wake up and forget everything. Okay? Go home and study. Every single video I've recorded and sent to you. Please look through the videos. Got it? Okay. Now, if you guys are done, those who are done, take out your notebook, exercise book, paper, whatever. Okay? We're going to learn a new chapter today. I must take my blood pressure before and after teaching you all. Alright. You are here before 1 o'clock. Oh my goodness. Today the stars have aligned. Huh?
Duration.
Or is it? Okay. Okay, today we're starting new chapter. Okay, so the chapter we're starting today is called thermochemistry. Okay, the concept is thermochemistry. You might have learned this before actually in in what in Form 3. In Form 3, your chapter thermochemistry. Okay, so for those of you who take Form 3, it's the same thing. The concept is the same. Okay, can? So, for example, if I have a beaker, okay, inside there is chemical A, and I put a thermometer, all right, and I pour in chemical B, okay, and the temperature goes up. This is called an exothermic reaction. And I put my hand there, it feels hot. This is exothermic. So this is the baby signs you learned last time in Form 3. Like you learned before. Some of you learned in year 7, 8 also. Same concept. So if you put two things together and it becomes hot, it is generally known as a exothermic reaction. Okay, now let's go one up. Let's say it's not A plus B, it's B2 plus A2. Okay, let's say it's like that. So A2 plus B2 becomes AB to AB. So what we learn in our first two chapters is about chemical bonds. What is holding A with A? Bonds. What is holding B with B? Bonds. What causes A and B to form a new compound? New bonds. So what happens is in any chemical reaction, the first thing you need to do is break bonds. And the first question I want to ask you is, in order to break bonds, do you think they absorb heat or release heat? Absorb heat. Okay. In order to break bonds, you absorb heat. Okay. So break bonds, you absorb heat. Now, what heat is the energy, right? Absorb heat or absorb energy lah. What is the unit for energy?
Okay.
Kilojoules or joules, correct. Okay. So let's say in order to break these bonds, we give a simple number lah. Let's say 100 kilojoules to break A and 200 kilojoules to break B. Okay. So the total energy to break A and B is 300 kilojoules. Tada, 300 kilojoules. Okay. So when I break the bonds, A atom, B atom, now they are free. Okay. Now what happens is after that, they form bonds. Now, logic lah. If breaking bonds absorb heat, forming bonds release heat. Okay, so let's say in order to form every single AB bonds, it releases 300 kilojoules per bond. How many bonds do I have? Two. Two AB, so it's two. So the total energy release is 600 kilojoules. Okay, now we use simple terms. This triangle H is called enthalpy change. Okay, it's called enthalpy change. And enthalpy change is always energy in minus energy out. Very simple. So energy in is I absorb 300 kilojoules to break bonds. Energy out is I release 600 kilojoules. So total is how much? Negative 300. And you have to have vector. Okay, it must be positive or negative. As long as it's negative, it is called exothermic. Exothermic, you must always show it as a negative reaction. Okay, Ken? Okay, so basically, if they ask you, why is this reaction based on the bonds, why is this reaction exothermic? More energy is absorbed to break bonds, sorry, less energy is absorbed to break bonds, more energy is released to form bonds. That's it. That's your definition already for exothermic. If they show you one equation and they ask you, how you know this is exothermic? In the end, they will show you enthalpy change equals to negative 300 kilojoules, like that. Can you understand? Okay, so when you see the negative, you know it is a exothermic reaction. Okay, so can understand simple concept, right? So when you were in lower secondary, when you were learning last time, just learn exothermic means become hot, endothermic means become cold. Okay, now you learn how to calculate the bonds. Okay? Can? All right. Now, there's two kinds of energy level diagrams that is involved in this. The easy one is this. So this is energy. Okay? Basically, overall is I start out with A2 plus B2. Overall, it releases energy to form 2AB. Okay, and this enthalpy change is negative 300 kilojoules. Correct? Okay, so I cannot, okay, energy going down because its total is exothermic, so negative. This is the simple one. Okay, this is simple one. How do I know which one to draw? They will tell you lah. Okay, now there's another one where it's more complicated. I start out with A2 plus B2, right? What happens first? First, I absorb energy, right? How much did I absorb? 300. First, I absorb 300. Now, here's the question. If I did not break the bonds, would the reaction have occurred? No, I must break the bonds, right? If I only had 200 kilojoules, will the reaction occur? No. If I only had 100? If I had 299.9, no, no such thing. No such thing. A round up. This one not money. Cannot round up, round down. No. If I had 299.9, still not enough. I have to have 300. Okay, if I had 301, can or not? Can. Okay, so the minimum energy is 300. Who can tell me what is that minimum energy needed for a reaction to occur? Activation energy. You've heard this before. Okay, activation energy. So the activation energy is the minimum energy. So in this case, the symbol for activation energy is EA. Okay. Let me write this somewhere here. Okay, wait. I want to write down the definition. Okay, I write it below here. Okay. I'll let you draw first. Wait. I'll let you draw in a while. Can you just write down the definition for activation energy? Okay, because they always ask you. So activation energy. So minimum energy required for a reaction to occur. Okay. So the symbol for activation energy is EA. And you all remember what's delta H? Delta H is what? Enthalpy change. Okay, remember that, enthalpy change. Activation energy, they always ask this definition. The minimum energy required for a reaction to occur. So what kind of reaction is harder to happen? The one with higher activation energy or the one with lower activation energy? Which one is harder to happen? Higher lah, of course. Okay, burning petroleum, high or low activation energy? Low. What does it need to burn the petroleum? How much energy? What do you need? If you want, if the whole shell or the petroleum is on the floor, what is needed for it to go? What spark? One stupid fella just put the cigarette and throw it down. One spark. What spark is high or low activation energy? Very low. Just a little bit of energy. Okay, so reactions that happen very easily require very low activation energies. Okay, can? Right. So EA first I absorb, then I release. Okay, so this one is the in, is the 300. This one out is the 600. Get it? Okay, so usually what they do is they draw it as a like that triangle. Have you seen this before? Like not triangle, but a circle. Gosh, they draw it like a circle. Have you seen this before? Yeah, so they go up activation energy, then the total energy go down. But the enthalpy change is how much? The enthalpy change is only from here to here. Enthalpy change is only from here to here, here only. Don't get it confused. This is in, EA is in, this one is out. Okay? Teacher, how do I know when to draw this, when to draw this? They will ask you. They will tell you. Complete the energy level diagram. In your answer, include activation energy. The activation energy lah. In your answer, include the product and the total energy change. Here, that's it. Later when we do questions, we will see. Okay, can? Okay. Get it? Easy, yeah? So, endo, so to me lah, endothermic very easy lah. Endothermic is the other way around lah. So the endothermic, okay, so x2 plus y2 become xy2. So let's say in 500 kilojoules to break the bonds, and then out is only 200 kilojoules. So the enthalpy change would be 5. It's always in minus out. It's always break bonds minus form bonds minus 200. So must put positive 300 kilojoules. Okay, if they write kilojoules or kilojoules per mole, it's okay. So this reaction is endothermic. So the energy needed to break bonds. Okay, so more energy absorbed to break bonds, less energy release to form bonds. Get it? Okay. Yijin, you have no notebook. You try this now. All right, can. So obviously, how will this graph look like? Simple one. It will look like this: x2 plus y2 go up. Ta-da! xy. Enthalpy change positive 300. Kilojoule and kilojoule per mole is the same. Okay, now I have a very important question. What if I ask you to include activation energy? Can you try and draw the one with activation energy? Draw. Try and draw the one with activation energy. This is the one without. So when I pour these two things together, will it become hot or cold? If I put x plus y and I put my finger here, cold or hot? Cold. A lot of students get very confused. If endothermy is absorbed heat, why doesn't it become hot? It absorbs heat from the surrounding. Your finger is the surrounding. The solution is the surrounding. The chemical it absorbs from heat energy, it becomes chemical energy. So the heat energy so-called disappear. So that's why it becomes cold. Get it? Okay. Draw the one with the activation energy and show me. Ah, correct. Okay, do you understand? Okay, so this one will be very simple lah. It will just be like this. Okay, so I start with x2 plus y2. Okay, my energy in will be more. My EA will be higher. That is very ugly. Okay, wait. 2xy. Okay, and my enthalpy change will also be going up. What was it possible? What? 300? 300 kilo. Get it? My EA is also going up. My enthalpy is also going up. Can you see? Can you see the difference? So they will ask you, show you the graph and ask you which is which. Okay? Okay? All right. Now, we almost have a full class today. Huh? The girls are not here, ma. They went to Servan for something. I think Servan, I can't remember. Okay. Apparently, I heard the only reason you all listen in chemistry class is because I scold you all. Okay lah, to do lah. All right. Ready or not? Ready or not? Who is serious in other classes? He's You are hardly serious in this class.
Hey, I'm very serious in the other class. You just don't think I am.
One exam is 700 in Sri Amas. If you take it in British Council, it's 1,000. Just to let you know. Okay, Jaren, how much is your one? Yours? Okay, I ask you. I ask and not ask the same one. How much is your paper in school? Take in school or take outside? How much?
Not sure.
Not sure. I haven't signed up. Huh? 800. Take in heritage is 800. I think UCSI should be able to also sell 800 lah. Per subject Per subject. 7 to 800 per subject. I think I paid 750 for my son.
7,801.
Per subject.
Maybe you have to leave out.
Never mind. Yes, yes.
Oh,
You take your exam.
oh.
Okay. Huh?
What thousand something?
Thousand something is you take in British Council.
What British Council? Sorry.
British Council, you know, consulate, like we are in Malaysia, right? So if let's say you go travel to Japan and you get into trouble, your passport got problem, then you go to the Malaysian embassy.
Oh yeah.
Yeah, so British Council is like something like the British embassy here, but it's not really lah. But British Council here deals with all the British education here. Yeah, so they do like IGCSE, all the British education, everything. So you can go and take exam there.
Oh.
You can because okay, let's say your special needs and your special needs is I had a student last time, he has problem where because of his ADHD he took medication, because of his medication he has tremors. Okay, so he really cannot write. You ask him to write English essay, you have to decipher what is he writing. So so his mom signed him up for British Council. In British Council they will give you a laptop and you type out your answers.
Oh.
So now they have other things also. They have scribes, but I think only British Council gives you a scribe. So remember my little genius, my little genius. Okay, my little genius. He cannot hold pencil ma. He's dyspraxia. He write very messy one. So he has a scribe. He tells the scribe, and then scribe write for him.
What's the whole man?
It's a scribe lah.
What's the
Yeah, but he's really you have to go. You cannot simply say. So the scribe will write for him lah. But for his math, he didn't ask the scribe. He write himself. But still can get A or
So what? Yeah, you guys right?
net 3 because 3 is like 5 minutes from my house.
Oh, really?
Yeah. So 3 is cheap lah and okay lah. So I signed Ben up also 3. Okay, do this question. Do this question. Quick. Calculate. Sorry. No wonder.
No, we are going to calculate with you.
Okay.
John's paper. Oh.
It's not this paper. That's why I'm asking you to do this question. You don't have to write down the bond energy if you don't want to, but do this question. It's very simple. It's like the easiest one, guys. Come on. So you're supposed to calculate the bond energy.
You don't need to draw.
No need to draw, just calculate the bond energy.
Figures.
In an exam, when you have a question and you don't know what to do, what do? You pretend you know what to do. So what you do is you pretend to write something will come out. First, you calculate energy in. Okay, iodine is 151. That's the bond energy, ma. Just now I was giving you fake bond energy. Now this one is real. And then chlorine is how much? 242. So you add it together, lah. Get it?
应该是有。
Okay, and then energy out. Okay, so here is 208, right? Then iodine, they give you ICl 208. But how many do you have? 2. So you multiply 2.
Oh.
Okay? And so enthalpy change. Negative 23 kilojoules per mole. And then so is this reaction exo or endothermic? Exothermic. So they will ask you things like, is it endo or exothermic? And then you reply exothermic. And then they will ask you things like, how do you know it's exothermic? And then you say, because the enthalpy change is negative. Okay, can? All right, let's do something a bit more challenging. Huh? What? No need? Okay. Ready? You get it? You get it?
Yes.
Okay. Now, let's say they give you like, oh, sorry, Jai, were you done? Okay. Now, let's say the question give you like this. Okay. NH3 plus 3 F2 become NF3 plus 3HF. Okay, let's say they give you something like this, okay? And they give you the bond energy. I'm going to give you the bond energy now. I'm going to send it to you in your group chat because I don't think we can flip up and down. Wait, but let's see first.
Don't know yet. How's it going?
If you don't have your phone, it's okay. So I'll project it. It's just that in case you want to see. Today you have economics test next week.
Mm-hmm. Next week. Next week, but today.
Next week. Okay. So okay, write this down first, write this down first. Write this down first. Okay. I send this to your group chat. I will share here also. Okay. This is something where okay, bond energies here. This question is something where you cannot just look. You cannot just look. Nothing is going to happen if you look. Okay, so this is in and this is out. Betul? In, out. Correct?
I think it's facing.
Huh? Oh, sorry. Uh, this is in, this is out. Correct? Okay, they give you NH bond, they give you FF bond, all that. What do you think you should do first?
And hopefully, water together.
Draw the bonds. The first thing you should do is draw the bonds. Right or not? That's the first thing you do. Do you know what to draw? You draw the displayed formula. You know what I'm talking about?
False.
Okay, draw. N H 3 F F F. Because it's 3 becomes N F 3. Sometimes they draw for you, sometimes they don't draw for you. HF HF HF. Get it? Okay. Energy required to break bonds. Calculate energy in, calculate energy out, and then calculate the enthalpy change. Okay? Okay, do it now.
This is too bad.
Okay, done? Oh my goodness. Okay. Now I was trying to do something. It's a bad idea. Okay, ready? Can I discuss, please? Yes. Okay. Okay. So in is how much times how much? Is three times. So here you can see lah. 1, 2, 3. Correct or not? So 3 times 390 plus 3 times 155. How much you get? 16. 1635. Correct, ah? I'm trusting your calculation, ah. I don't know what, ah. Correct, ah? Your press calculator also press wrong. I have no words to say, okay?
Yeah.
Okay, out is
253.
2, 25,
53.
2535. Okay, correct, ah? So enthalpy change is 1635 minus 2535. Get it? You get?
Negative 3. Right.
Negative 900. Ah, correct, negative 900. Apologies.
That's right.
Okay? Can? Alright. Okay, let's do one more. Okay. We do this and then we're gonna move on to something harder. Wait, okay, this is a bit different. You read this carefully. You read this carefully. This is asking you to find the unknown. Okay? It's not so straightforward. You read carefully, you read carefully. Okay. Now, wait. All right. Look at this. Okay? They give you they give you the energy. They give you the energy change for this reaction is negative. Okay, they give you already, yeah. They're asking you to count CCl bond. Okay? So it's basically finding X. Get it? They give you steps. Okay? Okay, try. Try first. Wait, I count. 4 times 410. 4 times 410 plus 610 plus 240. 2490. All of you count round now.
Why I got 2
Then why you never say anything? I asked whether everybody got the same answer. Oh, MP 2490. Okay, thank you. Yeah. All right. Use your answer from step 1. Change the reaction to determine the energy release. So enthalpy change equals to in minus out. Does that change? No, that doesn't change. How much is enthalpy? Enthalpy change is negative 180. How do you know that? It's given in the question. In is 2490 minus out, which is what you're looking for. Okay? The question is asking you energy release when bonds are formed. Is energy out lah. Remember I told you? I lazy to write so much. So energy release when bonds are formed is energy out. Okay? So this part is algebra. Out is
Was
out is 2490 plus 180. Berapa?
2 No.
Okay, everybody got this correct? Everybody got this part correct?
Yeah, I have.
Okay. Now step 3. Can I? I need to put it here. Okay, so step 3. Wait, text box. Okay, step 3 is use your energy in step 2 to find CCl. Okay, how many CCl do you have? You have 2 CCl. Okay, so 2670 equals to 2x, CCl is x, okay, plus CC bond, 1 CC bond, right? 350 plus 4 multiply CH 1, 2, 3, 4. 410. Is that all? Yeah, so you just have to find x. Okay, so minus 340. Who got 340 just now? Anybody got 340? Okay, now do you get 340? Or did I count wrong still? 2670 minus 350 minus 4 times 4 or 10. 680 divided by 2, 340 lah. Correct, right? Didn't you get that? Okay, this one is algebra. This one I can help you. 'Do you understand? Who is who is not understanding? Can I get Okay, the answer is 340 ah. Can? Do you understand why or not? Does everybody get it? Okay, if you're done, Shrini, okay? Okay, do this question.
Yeah.
You use the same method. Okay, ready? Any answers?
115.
115. Okay.
Oh, 195.
195. 195, 115. Any other answer? Trenton? There's three information given here. The first information is the enthalpy change. The second information is the FF bond. And the third information is the equation. Okay? You just have to remember one concept. In enthalpy change equals to in minus out. That's all you need to remember. Okay. What's the enthalpy change? No, 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 no. 780. The first question, wait. Positive or negative? That's why you want to know. Amount of energy given out means this fellow is exo or endo. Exo means positive or negative. Negative. Okay, now try. Continue. Now try again. Are you done? Okay, now what's your answer? 275. Okay, let's see. Okay, in is 160 times 2. Why is it 160 times 2? Because it's 2F. And then minus out. Out is what? That's F ma. S is element. Element got nothing to break, right? It's alone. You only break. So you only break when there's something to break. There's alone, nothing to break. Okay. Yeah. It doesn't do anything, right? So how many books do you have for F? Like that. So X equals to 275.
Oh. Ah.
Do you understand?
Yes. Very on.
Yeah.
Yeah, yes.
Yeah, correct. You just solve the algebra equation. You just find X.
Yeah, and that's the square. Long square or compromising.
Okay, please go back and study this,
This is keep on watching.
Okay, let you finish, let you finish. Okay. Are you guys done?
Yeah.
Done, Okay, so all when I have okay, don't talk about electric cars, but most cars are petroleum. Huh? Okay, petroleum is a fossil fuel, right now. When you burn fossil fuel with oxygen, what do you release? Carbon dioxide. And this is a greenhouse gas. Okay. So one way of changing it now is we use electric car. But then again, where do you get your electricity from? Like Malaysia, we get from hydroelectric, but we still use fossil fuel to get electricity in some places. Okay? What if we use something called a hydrogen fuel cell? A hydrogen fuel cell is when hydrogen burns in oxygen to produce water. Now, same as every single reaction of combustion, this is very, very exothermic. But we're not going to just put hydrogen and burn and then whoo, see what happens. No. What we do is we change it into a battery. Now, when we change it into a battery, what happens is we pump the hydrogen until it becomes a liquid. We pump the oxygen until it becomes a liquid. All right? And then we force them to react and pass through an electric wire. In the middle, we put electrolyte. What truly happens is the electrons move from hydrogen to oxygen. When electrons move, what does that generate? electricity. So by forcing the hydrogen to react with oxygen, we are forcing the hydrogen to release electron, and it goes to the oxygen. Oxygen absorb the electron, and therefore electricity forms. Overall, the reaction is still the same. Okay, this is called a hydrogen fuel cell. It has been invented already. Is it better or worse than petroleum? Much, much better. Why? Because the product is only water. So when there's only water, so the advantage is the product is only water, so there is no greenhouse gas form. So that's the good part. Okay. The bad part is what? Tell me what's bad about this. Okay, why we cannot say flammable? Everything is flammable. Every single fuel out there is flammable. If it's not flammable, then it's not a fuel. Right now, what's the point of having petroleum that cannot burn? You get it? Alright, so cannot say that. Hydrogen is a gas. Is it easy or difficult to transport? Difficult, because you have to compress it. It's very difficult. Petroleum is liquid. It's easier to transport and store. So the disadvantage, you cannot say flammable. Advantage is difficult to store and transport. Okay, please write this down. This is the last part of the electrolysis. They won't ask you to write the equation. You only need to know the overall equation. Okay, and it produces electricity. That's all you need to know. Okay, please study. Next week we got more calculations to do. Yay, I'm so excited. Oh. Okay, y'all cannot be like Dory Fish and forget everything we learn like that, okay?